So part 2, we're going to move on from just defining an inverse and defining if something is one-to-one to dealing with one-to-ones. So we are going to be finding the formulas for inverse functions where they are one-to-one. So you'll notice that the wording in the question always starts with for these one-to-one functions, okay? And so what we're going to do first is we are going to find the formulas of inverses. Now we already sort of did this, right? We did this back in this example here, right? We had a relation y equals x squared minus 5x, but because this wasn't one-to-one, we just left it as x equals y squared minus 5y, right? Plus it's really complicated to take this equation and solve for y. We don't need to write it as a function, so we just left it like that. Whereas these ones, we are going to go a step further. So we are going to be finding the formulas for inverse functions where they are one-to-one, and you're going to be expected to use function notation. So all of your equations are going to start with f of x equals. So your first job is step 1, which is to replace the f of x with a y. So you have to recognize that f of x is y. All right, then step number 2 is that we are going to switch the x and the y values because that's how we take the inverse. So this is the step where you actually take the inverse. Now we're going to take this equation and solve for y. So to isolate y, now I'm going to give you a big hint. You know, usually in class I let you try this and I'm like, oh, hey, but you should have done this. But in the video I'm just going to show you, is that try to make the y value have a positive coefficient because it's going to give you the answers that you get in the back of the book. In other words, I'm going to add 3y to each side. So I get 3y minus x, plus x is equal to 2. Then I'm going to subtract that x. So that I get 3y equals 2 minus x. And then to isolate y, I'm going to divide by 3. You end up with y equals 2 minus x over 3. To write that in function notation, you would get f inverse of x equals 2 minus x over 3. If you hadn't done it this way, so if you hadn't isolated the y to make it positive, all that's going to happen is you would have subtracted 2. You'd get x minus 2, I'm just going to put a squiggly line, equals negative 3y. Then you would be dividing by negative 3. Now, is that okay? Can I get an equation y equals x minus 2 over negative 3? I mean, technically, it's mathematically correct. But it's kind of a math rule that we don't like negative numbers in the denominator if we can help it. And so what you would want to do is multiply the top and bottom by negative 1. So you would get negative x plus 2 over 3, and then you could rearrange it, or just be okay with the fact that these two are the same. Okay, so just be okay with that, but ideally you're going to write it as a question that looks like this. All right, so pause the video and see if you can take the find the inverse equation for this function. So hopefully you pause. So my first job is set y equals 8 over x. Then I'm going to switch my x and my y values. And then I'm going to solve for y. So I'm going to multiply both sides by y. I'll show it solve by y because then my denominator goes away. I'm left with xy equals 8. And then to solve for y, I'm going to divide by x. We get y equals 8 over x, and then I'm going to replace it. So f inverse of x equals 8 over x. What do you notice? Well, hopefully you notice that these two equations are actually identical. Now, to prove that to you, what I want to show you is just on Desmos, is that why did we end up with the same equation? Well, if I graphed 8 over x, and then let's also put in the graph of y equals x because that helps you see it. So this is that line that you should be reflected over, is that if you look at this graph, y equals 8 over x, it's already a reflection, right? This red part is a reflection of this red part. This red part is a reflection of this red part. So if I switch my x and my y values, it's just going to end up with the exact same graph. So that can happen. All right. Now, next little bit. This next little bit is rational functions. So this is actually not anything new. I'm not going to even talk about this yet. I'm going to say that I want you to find the equation of the inverse of these given one-to-one functions. First thing you're going to do is replace f of x with y. No different. Then you are going to swap the x and the y. So we get x equals y over 2y plus 1. Now you want to solve for y. Okay, now this is why I gave it its own section. These are very specific. And what it is that you've got a y up here and a y down here, and you want to solve for y. Well, how are you going to do that? Well, the first thing you should do is try to just get rid of having a y in a denominator. So we're going to multiply both sides of the equation by 2y plus 1. And so I get x times 2y plus 1 is equal to y, because the denominator would cancel out. Now I've got a y on the left and a y on the right. So the next thing you're going to do, so this is still in step 3. So we've replaced f of x with y, we've interchanged x and y. Now we're in the multiply step. So we multiplied the denominator, right? But we're also going to multiply it by distributing. So I end up with 2xy plus x is equal to y. And now what I want you to notice is that you have y's on each side of the equation. You have a y term on the left and you have a y term on the right. So this is where you're in step 4, okay? And you will get stuck if you do not do this. You have to put the y's on one side of your equation. So I'm going to subtract 2xy from each side. And I end up with x is equal to y minus 2xy. Now here's the next important step. Okay, step number 5, you're going to factor out the y. So I want you to notice that these two terms have a y in common. So I can greatest common factor it out. I'm left with y times y divided by y is 1, and then negative 2xy divided by y is negative 2x. Then to solve for y, I would divide by 1 minus 2x. So I would get x divided by 1 minus 2x. And that is my answer. So the inverse of f, so f inverse of x, would equal x over 1 minus 2x. And so again, you're going to get stuck unless you follow this process. It's why I gave it its own steps. So I want you to pause the video right now, and I want you to try this second question. All right, so hopefully you're feeling good about this. So the first thing I'm going to do is replace f of x with y. I get y equals 3x divided by x minus 5. Now I'm going to switch my x and my y, so I get x equals 3y divided by y minus 5. Okay, step 1, step 2. Step 3, I'm going to multiply. So the first multiply is I'm going to multiply by the lowest common denominator. So I get x times y minus 5 is equal to 3y, right? Because I multiply both sides of the equation by the lowest common denominator. Now I'm going to distribute multiply. So I end up with xy minus 5x is equal to 3y. Now my next thing I'm going to do is put my y's on one side. Now here's a really important part. Just like I was talking about with this one, where you want to end up, like the one before, where you wanted to end up with a positive y coefficient, same thing here. If you want to get the answers in the back of the book, try to make it that the term that doesn't have the y, make it positive. So since this is a negative 5x on the left, I'm going to add 5x to move it to the right, so it's going to be positive, which means I'm going to subtract 3y and put it on the left. So I would end up with xy minus 3y is equal to 5x. Now saying that, if you went the other way, it's okay, right? You would end up with negative 5x equals 3y minus xy, but you're not going to like the look of the answer as much as you're going to like this one. Okay, so now I've put my y terms on one side, and now I'm going to greatest common factor out the y. So I'd be left with y times x minus 3 is equal to 5x, and then I'm going to divide. Y equals 5x divided by x minus 3. And then I would write it in function notation. So the inverse of function of x is 5x over x minus 3. That is the way that you'll see it in the back of the book. It's the way you'll see it on multiple choice tests. But if you had done it this way, I just want to show you that it's not wrong. So you'd greatest common factor out the y, you'd have 3 minus x is equal to negative 5x. And you'd end up with y equals negative 5x over 3 minus x. So it's the same, right? Instead of positive 5x, I have negative 5x. And instead of x minus 3, I have 3 minus x. They are the same. I can't say that enough times. So you could make them the same by multiplying top and bottom by negative 1, right? If you multiply by 1, it doesn't change your expression. So just be aware that if you get a different answer than the back of the book, you're not necessarily wrong. You just might have put your y's or your x's on different sides. All right, last page of this note. So now let's kind of go to like a nice put it all together question. So this question says, find the inverse of the given one-to-one function. Okay, so they've told you it's one-to-one, which means we can find the equation of the inverse. It's funny, it doesn't specifically say equation, but that's what they mean here. So they want you to find the inverse of the given one-to-one function. So that's the first thing. Second thing, they want you to give the domain and the range of the original function and the inverse function. And then they want you to graph the regular function and the inverse function on the same set of axes. So let's do this in the order they give it, but just know that if you can't do domain and range without the graph, then just graph first. It doesn't really matter. But first thing we're going to do is find the inverse because we've been practicing this. So I want you to take this equation and solve for y after you've switched your x and your y values. So you could pause it if you want. Okay, first step, put y equals 5x plus 8. Now switch your x and your y's. X equals 5y plus 8. And now we're going to solve for y. So I'm going to subtract 8. I get x minus 8 is equal to 5y. And then I'm going to divide by 5. And you get y equals x minus 8 over 5, which means I can write it as the inverse function of x is equal to x minus 8 over 5. Okay, sorry if I went too fast. You can always pause the video and check. But I wanted you to notice that I wrote it like this on purpose. So this is my original function. This is my inverse function, and it's got this big fraction. If you took Math 50 with me, you might be trained to be like, I'm going to divide each term by x, or 5, and I get 1/5 x minus 8/5. And that's great. It's in y equals mx plus b form. But all of these equations in Math 60, we just write as a giant fraction. So we've done step 1. We found the inverse. Step 2 is to give the domain and the range. So let's see if we could do this without a graph. This is requiring a lot of knowledge of functions here. So if I asked you the domain of this function, the first thing you want to think of is, well, what kind of a graph am I expecting? Well, if I look at it, the highest exponent on x is a 1. So this is going to graph a linear function. Now, do you know the domain and the range of a linear function? Maybe you do. Maybe you need to think about it a bit more. What you have to ask yourself is there anything limiting my domain? Is there any value of x that I can't multiply by 5 and add 8? No. In fact, every linear function, unless it's a vertical or horizontal line, has a domain of -infinity to infinity. What about the range? Well, it's a linear function, which means maybe you think of it as an odd degree, right? It's an odd positive. It's going to start in quadrant 3. It's going to end in quadrant 1, right? This is my end behavior. While my range is also -infinity to infinity. Okay, so what about the inverse? Well, we know that we can just switch them. So if I want to find my domain of my inverse, I take the range of my original function. If I want to find the range, I take the domain of the original function. Or I could look at the fact that this is still linear. Either way. Okay, now I want to graph these two. So now I found my domain and my range. And now I want to graph them. So I'm going to graph the original function. Now, Math 60, it's funny how they don't focus on like graphing using y or slope intercept. They just say that you can use a table of values. So, you could plug in a value of x is 0, 5 times 0 is 0, plus 8 is 8. So there is a 0.08. And then you could plug in maybe x is -1. 5 times -1 is -5, plus 8 is 3, and I could get a negative point. If you have a knowledge of math, or lines, I should say, then you might look at this and say, hey, this graph has a slope of 5 and a y-intercept of 8, right? Y equals mx plus b. So instead of doing points, I could just say, okay, well, the first point I'll do is still that y-intercept of 8, but then I'm going to go down 5, left 1, down 5, left 1, down 5, left 1. And then I'm going to connect these dots. And again, you're going to use a ruler. I don't have one that I can put on the screen. So I'm going to connect my dots the best I can. So there's my original function. Okay, so I'm going to label it f. Now I'm going to do the inverse. Now, totally up to you. Do you want to do the inverse from here? Do you want to put in values of x and solve for y, right? Do I want to put in values of x and solve for y? If you do, maybe look at your inverse function to decide what. So for example, if I put in an x value of 8, 8 minus 8 is 0, 0 divided by 5 is 0, right? Or you can just take these points. So I have a point here at 0, 8, and it's going to go to 8, 0. I have a point here at negative 1, 3. It's going to go to 3, negative 1. I have a point here at negative 2, negative 2. It's going to stay there at negative 2, negative 2. I have a point here at negative 3, negative 7. It's going to be at negative 7, negative 3. You could also look at the slope, right? So instead of having a slope of 5 over 1, it has a slope of 1 over 5. Okay, but I'm going to connect these dots. And then I'm going to label it that this is my inverse function. Okay. If you wanted to make double check that you did it right, what you could do is add the line y equals x. So a line y equals x is going to go through 0, 0 with a slope of 1. And you can add this line on. And what you're checking is that anywhere your original graph crosses this line y equals x, like here, then sorry, it's not there, it's here. It's just off by a bit, right? So anywhere that your original graph crosses this line y equals x, your inverse does as well. And then you're looking for it to be reflected across that line. All right, this would have been a great place to stop this video. Actually, you know what? Maybe I will. Then I'm going to come back and make another video for this composition.